All right, so lights off, right? Okay, so I'll get those lights. 1G, so this is the last section of notes that will be on that test, is product optimization. And so write yourself a little stat box, so we will get to that stat box. So what do you guys think about when you think of like the word optimization? Optimize. Does anything come to mind? What about like optimal? Have you ever heard of like optimal performance or anything like that? We got nothing? Okay, so when we talk about optimization, we're trying to like maximize profit or maximize area or get the most. We want the most, we want the best, we want as much as we can get. So we can use quadratics for that optimization. So in order to optimize, you need to find the minimum value or the maximum values. In other words, find the vertex. So if we've got a quadratic that is opening up, then we would want to look for the minimum. If we've got a quadratic that's opening down, then we want to look for the maximum. And so we did a little bit of work with the axis of symmetry in section 1C. The formula for the axis of symmetry is in your formula packet. So it's in like the same section where quadratic formula is. So if you don't know the formula, you can look in that packet. But the formula for axis of symmetry is x equals negative b over 2a. And that's when we have our functions in like general form or standard form. And so what we will do is we'll have to use the axis of symmetry. And the axis of symmetry will tell us like the line that's right down the middle. But then what we have to do is we've got to plug that back in to find the y value, because we know our y values are vertical, going up and down. So to get the minimum value, it's really going to be the y value of our vertex. The maximum value will be the y value of our vertex. So we're going to start with two examples that are kind of on the basic side. Here's an equation, find the maximum or minimum value. And then we'll get into kind of a multi-step word problem with product optimization. So here is our first example. So it says find the minimum or maximum value of the quadratic function. The next two examples are going to have the exact same set of directions. So find the maximum or minimum. The first function we're going to look at is y equals 2x squared plus 1x minus 1. And so I noticed that it is opening up. So in this case, I am looking for a minimum. So just to kind of keep that in mind, since a is positive, opening up, I'm looking for a minimum. Remember, we're going to use x equals negative b over 2a for that axis of symmetry. So if I start that work, b is 1, so I've got negative 1 over 2 times 2. Some of this stuff is not the cutest, but we'll get through it. We end up with negative 1/4. So our axis of symmetry, the line that's right down the middle, is at negative 1/4. Remember, we talked about how the minimum value is actually that y coordinate. So what we're going to have to do is plug this in to both of those x spots on our original function to figure out what y is. So y equals 2 times negative 1/4 squared plus 1 times negative 1/4 minus 1. And so decide if you want to do some of this arithmetic by hand, or if you want to use a calculator because there's fractions in there. It's really up to you. Just make sure that if you're plugging everything in, you're being very careful with like your exponents, your parentheses, your negatives, and all of that. If I start evaluating some of this stuff here, negative 1/4 squared is 1/16. Can multiply that by 2, so I'm going to end up with 1/8 plus the negative 1/4 minus 1. And sometimes I don't always trust like plugging it in, so I kind of do what I can do. Now I got to this point where I need common denominators. That's where I'm going to reach for my calculator. And I end up with negative 9/8. So we're actually going to state this a little bit with like a sentence. So the minimum is negative 9/8 when that x value is at negative 1/4. So the lowest point in our graph is going to be at negative 9/8, and that happens on that axis of symmetry when x equals negative 1/4. Are you guys ready to try one on your own? So once again, it's going to have the exact same set of directions. So find the minimum or maximum value of the quadratic function y equals 7x minus 2x squared. So I can throw in a couple of curveballs at you on this one. So take a minute or two to see what you can do with finding that axis of symmetry. Alright, so hopefully we noticed that this was not in descending order. So that means that the A is negative 2 and B is 7. C is 0, but we don't really even need C for our axis of symmetry. Did you guys all catch that? That was like the curveball. So then when I plug that in, I end up with positive 7/4 because those negatives cancel out. And then we plug that back in. And and what you hopefully got was 49/8. Now, is this a maximum or a minimum? That's the other kind of curveball I was thinking about that. Very good. When we look at that A value, since that A value is negative, that means that our parabola is pointed down. So the maximum is at 49/8 when x equals 7/4. So taking, a couple seconds to think about it, is it a maximum or is it a minimum? Alright, we are going to hit up the step box just really quickly and then do that more complicated problem. So, the step box just says, how do you find the axis of symmetry and the vertex of a quadratic function? I just erased it off the board. There are multiple different answers, but just think about the one we've been using. How do you find that axis of symmetry? Write that formula right here. X equals negative b over 2a, so that you can turn, look at your step box, there it is. Maybe write a reminder, hey, substitute it back in to find the y. Whatever it is that you need so you can remember how to find that vertex. And then we have this doozy here. So it's going to have two parts. It's got a two-parter. There's a little bit more to it after we do this part. But it says, Karina is planting a garden. She wants to use a rectangular shape. She has 44 feet of fencing. The area of the garden is a square centimeters. Show that A, or area, equals 22x minus x squared, where x is one of the sides. Hopefully you're noticing that phrase we talked about yesterday. It is a show that problem. So you can't turn to the back of the book and get a hint on this one, because the answer they want us to end up with is this expression right here. So we have to show how we can get from this given information, which is not too lot, it's a rectangle, 44 feet of fencing, and x is one of the sides. How can we use those three pieces of information and come up with an expression for area? Keep in mind, we know area is length times width, or base times height, right? If you don't know, it's in your formula packet. So that's something we know. We've got a rectangular shape, and thinking back to geometry, when in doubt, sketch it out. So I'm going to sketch out this rectangle. Well, I know that in a rectangle, my opposite sides are congruent, so I'm going back and using congruent marks that I learned to use in geometry. I also know that A is one of the sides. So like if this side is, X is one of the sides. So if this side is X, we know that side is X. So we've pretty much used all the information except for that 44 feet of fencing. Is everyone okay so far? Now, 44 feet of fencing, that's like perimeter, right? So that means if I go around this garden, I've got 44 feet to use around it. I've got the perimeter. And we know, you should know, that perimeter is, like I said, adding up all of those sides. So what if I take the perimeter, or that fence, 44, and I take away 2x from it? So I take this side and take that side from it. I mean, I don't know what x is, but let's say x is 8. That means I'd have to take away 16 and I'd have whatever's left for the other two sides, right? Well, I need an expression for just one of these. I gotta figure out what I could write down on those sides, because I have to do length times width or base times height for my area. subtract the 2x, that's this side and that side left over. Well, if I've got two things and I just want one of them, I can take that and divide by 2 to come up with that other expression. I know this is a little bit weird, but it's one of those things that you're going to have to kind of think outside of the box when you get to your assignment and put yourselves. We've got 2 days of review before the test, so you'll have plenty of time to ask questions. So with this, I can divide 44 by 2 and 2 by 2 and end up with 22 minus x. So this side is 22 minus x, and that side is 22 minus x. So then, if I'm calculating that area, or writing an expression for area, I've got length times width. Well, here we go, we've got length times width, or whichever, it doesn't matter. So I end up with x times 22 minus x. And sure enough, once I distribute that, we've got 22x minus x squared as an expression for the area. So I know that's a little bit weird. Again, we're going to have to try it, kind of think outside your box, think of how can I use that information to write an expression. Now, none of this had anything to do with product optimization, so that's what part 2 is. So it says, what are the dimensions for the maximum area? So my area formula was 22x minus x squared. Because there's a lot of different things. I could make x 8 and figure out like what those other sides were. But for this garden, we want this garden to be as big as possible. So that's where this optimization comes in. So I can still do what I was doing before, x equals negative b over 2a. So, once again, this one's kind of turned around. So a equals negative 1 and b equals 22. All right, so I end up with negative 22 over 2 times negative 1. 22 divided by 2 is 11. So now, x is 11, so if I think about dimensions, that's like length times width. So if x is 11, then I'd have to do 22 minus 11. My length here would also have to be 11. So my dimensions are actually 11 by 11 to get that maximum area. And we're talking feet, right? Okay. So I did plug that x back in. It happens to be they're the same. It's not always the same. And if I did plug x back in here, I would find out that my maximum area is, I'm writing that down wrong, so 22 times 11 minus 11 squared. So my maximum area is actually 121 square feet. So that's that maximum area, but the dimensions are 11 by 11. It's okay if you're not feeling super right now. Give yourself a chance to think about it. This might not be an assignment that you sit down and you do start to finish right away. You might have to work on it, kind of step back, come back to it. Oops. Oh. All right, so then here is the assignment. When in doubt, sketch it out as a reminder.